Great clarification question. Let's say the client is the Department of Health and Human Services, HHS. They're using Confluent Cloud to power real-time analytics for public health data. For example, streaming data from hospitals and research labs to detect and respond to emerging health threats. Their key concerns include high availability, no data loss or downtime, strict FedRAMP Moderate compliance, data encryption and isolation, auditability and traceability, secure access for analysts and automated systems. Now, with that context, how would you design the Kafka-based data streaming platform to meet these requirements?
So, from my understanding, the DHS, or it says HHS, that I was trying to say, but HHS is a public health organizations, and they store public health data, and they also aggregate that data, and they generate reports based on that data. And those reports, based on the data that they're getting, can probably be used to, you know, maybe start a response somewhere else. So let's say the cities in California are getting a bunch of new COVID cases, and we realized that this thing spiked out of nowhere. And then we saw that now we're getting a spike in New York. Now we're getting a spike in whatever the other place might be. The spike can be maybe identified more quickly if we can get that data moving through the system very quickly. So, for that to be the case, that means every hospital or clinic or research lab that is collecting the data needs to be able to access this system. So, thinking about it's talking about how would you design the Kafka based data streaming platform. The data streaming platform itself is the platform that we're using to enable the type of near real time detection and response and collection, aggregation, all of that stuff. So the application or system relies on the frontline workers, being the hospitals, labs, and clinics, to be able to upload their data very quickly to this system. So that means we're going to have, and I don't know how many clinics, hospitals, and things that there are in the country. Let's assume it might be a lot. I was about to say 100 per state, but it might even be more than that. I know in Newark, uh, how many? There's at least Rutgers, then there's the University Hospital, then there's the City MD on Broad Street, and then however many. So let's say I'm gonna go with 10 per city. Let's even say a million in a country. There are probably more than that though. A million different health clinics that are all potentially sending data into this streaming platform at the same time. And I guess how big is the data? That would be something interesting to think about. What does health data look like? What does public health data look like? Is it large? So are we going to have a bunch of x-rays data being sent? And maybe you don't have to send the x-ray. If I was to think about this as a platform, maybe I don't have to send the x-ray data itself to let the federal organization know that this is happening. What if the event is just a reference to the data? The data is being stored by the hospital themselves in their S3 bucket. And the federal organization has permission to access that S3 bucket. So they can handle, the S3 bucket can handle all of the access, who's accessing the data, who is, who has access to it, right? Those rules, requirements, things like that. But this platform, it just needs to get the they, the hospital over there to know, hey, you need to check for this. So I guess it depends if that downstream application, that would depend, is the, what's the next question I would ask? How much data is being, mm, I'm thinking like, when is the data from, what do you call it? When is the data from these health clinics being, like, how quickly does it need to be updated? It says real time analytics. So it needs to be powered in real time. And so if we're sending the actual payload of the data, that would look different. Do we, all right, I guess I'll ask that. Do we need to send the actual health data itself? Or is it okay if we send a reference to where the health data is so that the aggregate HHS system can do their analysis whenever they need? Or does the analysis need to happen in real time by the HHS? And even saying that maybe the HHS only needs an aggregate of the data that the clinic is actually storing.
Another excellent question. Here's the clarified requirement. The Department of Health and Human Services, HHS, needs real-time analytics, not batch processing. The actual health data, e.g. patient vitals, lab results, COVID tests, etc., is streamed into Confluent Cloud from multiple data providers such as hospitals and public health labs. This is required to detect patterns and respond to outbreaks quickly. Therefore, the actual data must be ingested and analysed in real time, not just references. The system must support low latency, high throughput ingestion with end-to-end encryption and strict access control. The data is de-identified at the source, but the system still must meet FedRAMP Moderate requirements. With that, go ahead and walk me through your system design.
Personally, like I said, I wouldn't send the data itself. I would just send a reference to the data because we're talking about X-rays. You're saying lab results. A lab result for one test, mm, it could it's just the result, right? It's not the actual test itself or the data that was used to test it, like the DNA, the cells, whatever, a picture of that. It's not that. This is the actual result, so it might be smaller. So that's not too large. Um, the clinic themselves need to use that data separately than the way HHS needs to use that data. So the result being, if we're saying a bunch of results, basically HHS is just tracking what is happening over here. Um, so they need to move the data, but they also, in moving the data, guess what do they need to do with the data in this data streaming platform? They just need to move it from where it's at to where it needs to go. What is HHS doing with the data? Are they just moving it from where it's at to where it needs to go? What type of analytics are going to happen on the data?
You're thinking like a true SRE and architect. Context deeply shapes design. Here's the full picture. What HHS is doing with the data. HHS is building a real-time disease surveillance platform. They're ingesting data from hospitals, labs, and state health departments to 1. Detect anomalies and trends, e.g. spikes in respiratory illness, flu outbreaks. 2. Trigger alerts to analysts and response teams. 3. Power dashboards used by public health officials. 4. Feed predictive models for forecasting outbreaks. 5. Correlate events across sources in real time, e.g. ER admissions plus pharmacy pickups, school absences. Key requirements from the data pipeline. Stream real-world health data, de-identified, via Kafka into Confluent Cloud. Ingest, transform, and enrich data on the fly. Apply business rules and anomaly detection in real time. Route events to downstream systems, e.g. alerting systems, databases, BI dashboards, ML models. Comply with FedRAMP Moderate across all components, encryption, auditability, isolation, access controls. Now, with this in mind, how would you architect the Kafka-based data streaming system in Confluent Cloud to meet these needs?
So there's a lot of things I'm thinking about right now, and honestly, all of these use cases should be handled separately, but we're building a platform that needs to be able to support these use cases no matter what they are. So if we're talking about triggering alerts, let's just get the data first. So the first thing I would do is create a point-to-point connection between all of our clinics, labs, hospitals, get their data, and we need to figure out how to get that into our system. That could be from any API that is able, to support the. So we could actually use Kafka specifically. We could just use Kafka. Like, what if we gave them? Because I'm trying to say the connection. We're talking about the messaging infrastructure. How are we sending the message to our data sites? So we could have it almost as all of these clinics publish directly into the topic, and then the Kafka topic, and then we're always consuming from that topic. I would put an API in between that just in case, because in order for how much security, well, we can secure who has access to a topic. We can do that through certificates. We can do that through IAM roles. Uh, we can do that through like username, passwords. But we're saying I wouldn't expect, well, if it's a human user uploading that data, because I was assuming that the data was being uploaded automatically with some type of system. But what if the system was getting updated with users, human users that are actually in like at the hospital scanning the test results, or it's a human who's on their phone taking a picture of the test results that they just got, or is it the lab directly sending the test results? So that entry point into our system matters. So how do we expect the users that are collecting the data to send the data to us? Will it be through an app? Will it be through an email? Will it be them sending an API request? How? And I see.
Perfect. Understanding data ingress is critical to designing the right system. Here's how data producers, e.g. hospitals, labs, state systems, are expected to send data. How HHS data providers send data to Confluent Cloud. 1. Direct API integration, preferred for real time. Hospitals and labs push data via REST or gRPC APIs, exposed by a secure ingestion gateway. Your team builds this. Behind the scenes, this API produces events into Kafka topics. The API is protected with mutual TLS and OAuth 2 or API keys, with strict rate limits and audit logging. 2. Kafka Connect or Mirror Maker for partners already running Kafka. Kafka Mirror Maker 2.0 or Confluent Replicator mirrors topics into the Confluent Cloud. This allows CDC, change data capture from on-prem databases too. 3. Secure file drops, fallback method. Some smaller providers batch deposit de-identified CSV JSON files in a secure S3 bucket or SFTP server. A Kafka Connect job, e.g. S3 source connector, pulls and streams those files into Kafka topics periodically. 4. Edge agents, optional for air-gapped environments. Lightweight agents on hospital networks buffer and forward data when connection is restored. Now, with full visibility into the consumer use case, data source methods, security requirements, and real-time analytics, please walk me through your system design for this Kafka-based streaming platform.
All right, so far, definitely gonna put an API in there for the initial data ingress. That should work for future use cases. The faster this gets, we'd also have to enable the secure file drops. Just because there may be some clinics and hospitals who aren't going to be able to set up an entire API application or I could do it for them. I could build a nice little Flutter app that could work on their desktop, mobile, or their a web app, so they could hit it from anywhere on any device. But let's assume they don't have me in place, unfortunately. So I would let them be able to just upload the files. Um, you still need some type of UI just to make that a little bit easier. So they need something, but well, you'd always need something because even when the results are printed, it just depends who's uploading it. Now that I think about it, you'd always need some type of UI. It's just who's going to be responsible for building that UI. But HHS is not going to be responsible for building the UI that they use. So let's just go with, hey, everyone in 5 to 10 years, everyone needs to be using an API or some type of automated method. It could be API or CSV. We don't care the data format that your it could be API request or file drop. We don't care what type of data format you're using. Once we get the data, however that may be. So if we use an API integration, then we can build the API. If we use a file drop, then we need to actually handle it needs to be real time. So we need to have some type of process in place, like a Lambda or some type of trigger. Oh, there are triggers. You could trigger a Lambda with an S3 file drop. So every time a new object is stored in this bucket, then it triggers this Lambda. I could even say every time a file is dropped in this Lambda, then and not in this S3 bucket, then it trigger this Lambda to send the API request on behalf of whoever just uploaded the file. Otherwise, they could just send the API request themselves. The API request is really my main source, right? From how we get the data, whether it be from the file drop or a direct API integration, is up to the client, and we give them some time to figure that out. So yeah, API. Then that API publishes the data into a. Now I'm thinking about it. Do we want to store do we want to store the data separately? Like, hmm, if we're talking about outbreaks, do we want to store the different, what do you call it? If hospital records are coming in at the same time that lab results are coming in, technically that data may not be the same. So are we adding that data together? Like, are there any relationships between are what's the difference between the data types that we're gonna receive? I can imagine the data that comes from a hospital may be different than the data that comes from the lab or a research center. So, will I need to store that data separately, or will the aggregations be matched across um, type or city or state? What is that relationship based on? It would be cool if you could do it. Could you anonymously could you anonymously send the data, but also once you sent the data, be able to match the data to a specific person? Person might be difficult, but you can do it to a city. Like, what if the aggregation that happens is fixed to a city and you only send the results for that to the specific city that needs access to it?
Excellent. You're anticipating data heterogeneity and downstream correlation strategy. Here's how HHS expects you to handle it. Yes, data will differ by source, but needs to be aggregated. Data sources, hospitals, ER visit logs, vital signs, admit discharge info, labs, test results, COVID, RSV, flu, research centres, case studies, clinical trial data, pharmacies, medication pickup events. Each has different schema, frequency, and sensitivity. How the data is correlated and why it affects your design. The goal is real-time situational awareness, so events are enriched and normalized by your streaming pipeline. Aggregation and correlation happen along dimensions like geography, zip, city, state, time windows, e.g. past 24 hours, syndromes, diseases, respiratory, GI, etc., event type, test result, visit, prescription, unique identifiers like facility ID, anonymized patient ID help stitch events together. Storage implications: store source data in separate Kafka topics per data type for ingestion and schema evolutionese, e.g. lab results, ear visits, medications. Use Kafka streams or KSQLDB to join and aggregate normalized data into materialized views, e.g. alert-worthy trends. Downstream syncs, databases, alerting systems. With that in mind, please walk me through your proposed system architecture, from ingestion to processing to delivery, and how you would ensure reliability, security, and observability throughout.
So, a key objective of this design is to understand the situation, like it says, situational awareness. What is a situation that we're describing, right? The situation for a health situation for a city can mean we have 20% of our population in the last 3 days, 20% of our residents have gotten sick with GI issues. I may need to send that information to the FDA because maybe the issue is in the food. I may need to send it to um, the local public utility authority, because maybe the issue is with the water. There are bacteria in the water, and we're not sure pretty much. So we're trying to answer that question with this system. So for all data, I would actually normalize it by zip code. That's not hard, but it's not impossible. So basically, I'm creating a snapshot of this zip code's health data, the number of ER visits, the type of information that happened in that ER, like the type of results we're seeing. Because ER visit logs could include an arm broken, which is not necessarily an issue to us, right? That's not necessarily a problem. It is a problem in correlation with um you know number of police arrests, maybe. If the police are the ones breaking the arms, that would be an issue. But it's also an issue if just in this zip code we keep finding, like, why does everybody break their arm over here? Is it the parks? Is the park not safe enough? Is there some type of gang activity that's going on that we're not that the police don't know about? Or maybe the local police know about it, but the federal police don't realize how bad it is. Or it could be a lot of different things, right? Whatever it might be. But they could be important together. But all right, so we're going to say by zip code, by time, and I want to say time could be, we want to have different time windows being measured at the same time, because the data we see over a 24-hour period, over an hourly period, because we get in real time, right? So we could say a spike could happen in a second, a spike could happen in an hour, a spike could happen in 5 minutes, a spike can happen in a day, a week, a month, a year. So we're getting from whatever that current system is doing, it might be only taking this data yearly, and it may be inaccurate. We're trying to get this down to real time. So let's say from 1 second, that's crazy. Now 1 second type, that's crazy. I'm saying it's crazy because saying 1 second type time windows for this type of data system is not an easy or simple thing to say. But it sounds good. Yeah, we got real time. All right, maybe we have 5 minutes. You feel me? Maybe 5 minutes is okay. Maybe 24 hours is okay. Maybe a day is okay. You might be wilding. Like, it might be, we don't gotta wait months. Maybe do we need real, like, second to second? That might be a lot. But, all right, regardless, that's a whole nother case. All right, so we're gonna correlate it by zip code. Well, you could correlate it by all of these things. We'll have different correlations. I'm not sure exactly how. Like, every data source will provide the zip code, city, state. Mm. It mentioned something about Kafka streams. I know Flink is able to do this type of just analysis on data. So maybe one of our subscribers to the initial data bucket, I don't know what to call it. We got the API, which is our entry point. This is called HHS, local health reporting endpoint, whatever. We're gonna call it that. That API will publish the data to a general, I'm wondering if I should publish it to different topics. Publishing it to different topics based on, because we might have different topics for each event type or geography or time window or syndrome. So let's have a different one. So we'd have a geography topic, we'd have a time window topic, we'd have a syndrome topic, we'd have an event topic. And honestly, all of the different data streams will have access to that same data. Like, we're not going to ever separate the geography data from the time data. We're not going to separate the event type from the syndrome. All of that data is going to go, but it's going to go down different streams. So we're going to have a geography topic, time window topic, syndrome topic, and event type topic. And that is how we get that's how we get our data. That's how we wrangle it a little bit. Because right now we getting it from everybody. But we getting it from everybody not because we could have given each of, for simplicity. That's why we made an API. Because we didn't want all of them having to choose between the different types and all that. So, depending on how specific, yeah. Basically, the API is there just to be a centralized place for all of these clients, hospitals, labs to send the data, whatever data they have. This API will figure out, all right, now that I have this data, what topic should I put this data into? And that will be the next leg of the journey for the data. And then the different topics will be consumed by different Flink applications. These applications will be able to create normalized views of that data. So it'll be able to say, we got this many syndromes within 24 hours, or this many events in 10032 zip code. Or within the last minute, it'll do that. Would have different topics and then different Flink apps doing that normalization over the time horizon. It'll create that itself. And then, all right, and then the Flink apps will then publish their results into another topic. And the topic will be like what do we want to call it? Because what is it for? This topic is now to take the analysis that Flink has come up with, and well, we could do a lot of different things with the data. We could alert the zip code. We could send this data to we can send this data to another research center. So maybe we could send this data back. Like, let's say we get a bunch of data from hospitals, and then we send it to a research center, because the questions and answers that we could get from Flink are not the same questions and answers that we'd get from an actual research team focused and looking at this data, having this data in hand. So, and then maybe, so that downstream, and maybe we don't need that real time for them. Maybe we don't even want that data accessible to the labs in less than 6 minutes, or that topic also has really important data that could be used to create new products. It could be used it could have a military purpose. Like, if let's say, I don't want to be that person, but let's say China found out about the data and knows who's getting sick. They know, yo, this zip code got a bunch of sick people, right? Right now. Let's hit them. They won't even see us coming. Let's hit them. They send a drone that get through our our anti-drone surveillance. But now the people sick, so they're not even looking at the sky. They don't know that there's a drone up there watching. Now, what if that drone was an attack? So we got to be careful about the because now this data is more valuable. The data that we first got, that's not really too valuable if somebody captured it. Like those first topics is valuable, but you would need to know the data a little bit more in order to ask the questions that we're gonna ask and get the answers, and just you gotta know it. So I guess they'd all have some type of data security requirement. Um, yeah, every topic, because if you could get the silver version of the data from the bronze, then the bronze is valuable. You just how long were you in the system? Were you in the system for 24 hours and you got 24 hours worth of data? Or were you in the system for a minute and you got a minute worth of data? That might be a lot of data, but it may not be a problem if you got it. Now that we're asking these types of analysis questions on that data, now it might be a problem if you get that data. Or if you get it for long enough without us realizing that you access that data. That could be an issue. All right, so data security requirements for all of the topics would be pretty similar, uh, and so that basically means we're not letting hospitals and labs and research centers access these topics like directly. That's not happening. So we might have one app that basically it could be batch, like, yeah, for any data that's going out publicly, where we'd only give you last year's data or last month's data. We can't give you real time. But we do need another path for when that data, a more secure route. So let's say we have an app that is just consuming that topic. And let's say they see a weird spike in symptoms for a city or a state or a zip code, and it said, based on the rules that it has programmed, it says, hey, this is a weird spike, let me send this out. And there's a lot of ways to program that. We could feed it into a model to basically determine what is abnormal, right? Because if you had all this data, you should have been able to build a fairly good model of what is normal, what's not normal. That's just normal, like machine learning. Pretty much, you could do that with like a regression model. Um, so now that I know what's abnormal results, what's outside of our regular, then if that app ever gets an abnormal or reads an abnormal result, then what it does is send an alert. It could use something such as, well, it could send a, it depends. How do we, so the people who need it in real time are public health officials who need to make decisions with that data. So if we're thinking about that part, there needs to be some type of alert and there needs to be some type of monitoring. Now, and then there needs to be some type of how do we communicate that, you know, because the I could send it as an email, right, to a person, an analyst inside of the Department of of health, whatever services, and they could basically take that email if they see it, because it depends how often they check their email. Take that email and run upstairs to go tell the chairperson of HHS. And that would be getting the message to them. And that's really what the requirement of the solution was. How do we get it from where it's coming from to where it goes? So that's my answer. Use an email. Just send an email. And yeah, I couldn't follow that just now, so I need to figure out a succinct way to give it my answer. Uh, Data sources access an API securely. The API publishes the data to topics based on the geography, time window, syndrome, and event type. Then I do like that. 2 type. 3, a Flink app processes the data and answers the questions. How many of this disease in the past? Of this disease event type in the past minute, 24 hours, week, etc., and where did they occur? For the answer to that question is published into a single topic B through a full 5 B. The a subscriber Go app is listening to events on topic B. So as normal. do. Assume the app to
That was a clear, well-structured response that reflects solid system design thinking. Here's feedback and a few follow-up challenges, strengths in your answer. System flow. You demonstrated a clear event-driven pipeline with secure ingestion, dynamic routing based on metadata, stream analytics via Flink, decision engine logic in a Go app, real-world escalation path. Architecture elements. Decoupling of stages, topics A1 to A4, Flink, topic B, app to ports, supports observability, horizontal scaling, and failure isolation. Using Flink for time-windowed aggregation is perfect for the past minute, past day, past week queries. App2 acting as a policy decision point that can store, alert, or discard is great for flexibility and compliance logic. Areas to improve or expand. 1. FedRAMP compliance handling. How are you ensuring the system logs and audits every action and decision, encrypts data in transit and at rest, especially between stages, ensures identity and access controls, e.g. who can read write from A1, A4 and B. Now 2, failure and back pressure handling. What happens if App2 crashes or falls behind, topic B gets flooded with alerts, a data source sends malformed or high volume spam?
Follow-up question!
Let's say App2 crashes and restarts 3 minutes later. How do you make sure it doesn't lose any critical alerts? And how would you design topic B to handle retries and replayability? Please walk me through how you'd ensure fault tolerance and data durability in that scenario.
Alright, so basically what it's telling me is that the system that I designed, if I had given a developer this system design, and I'm putting up quotes for a reason, this system design, if I had given them this system design, this would make their job harder and make it less likely for the system to actually be built in a reliable way. But technically, it could have gotten the ball rolling, and then we could have figured out the flaws later. But I'm glad someone was thinking about these other things. I'm gonna just mention them for you and I. I'm not gonna teach OpenAI how I would do it. This is between me and you. So, in terms of logging every action and decision. So, Kafka has a way, or Confluent Cloud specifically, has a way to monitor and log events, not events. I want to say access. Does it? I'm not sure if it does. Does Confluent Cloud have a way to log what operations happened on this topic? I know it can, specify access to the topic, and you can do that. I'm pretty sure it logs it, but if it doesn't, then maybe we don't use Confluent Cloud. Maybe we build our own Kafka cluster and use that cluster and set up some type of observability using Prometheus or Grafana or whatever in that cluster to basically monitor the Kafka runners, pretty much. We can log every user, like I'm sure the API was ours directly, but we can log all of the API calls. We can log every time a message is consumed from a topic by app2. We can log the emails, right? If your email server is being persisted, then you always have, oh, I got this email this day. Now, we can't log whether or not, well, we can log whether the analyst got the message. We can't specifically log whether the analyst gave the message. Because what if he's working for China, right? And he don't want to drop that info. Nah, I gotta stop. I gotta stop. Yo, all right. What do you call it? After we don't know that if he logged it, if he sent it for real. Encrypting data. So Confluent Cloud definitely encrypts your data at rest. And we could also do that ourselves if we wanted to build this cluster ourselves. But Confluent has done a great job of doing that. Encrypting it in transit. So you can set up different types of authentication between your consumer and producer when working with Kafka. So you can set up a username password, or you can set up TLS or mutual TLS, which require certifications. The cert is probably easiest to do if you can automate the cert rotation. Because, well, it doesn't matter if you do it with passwords or with certs, you still need to rotate those credentials. So I would leave it to the infrastructure engineer to figure out how, or DevSecOps engineer to determine what is the easiest way for them to rotate those credentials. And then you need to rotate the credentials without leaving the system unprotected and without leaving the system unusable, right? Like, what if you change a cert, but then the app 2 is using the old cert? So you got to be careful with that, how you rotate them. And you can potentially rotate them during a downtime, usually between two, like, I know I like to be asleep or at least home by 2 a.m. in the morning. Maybe we, every 3 months, between 2 and 4 a.m., we rotate certs. And you have to be careful you're not rotating certs while a new deployment or release is happening, because that might just throw people off and it's just not good practice. So think about it like that. What happens if app 2 crashes? So the great part, well, I know SQS does this, where you can pull a message, like the topics, we can set up basically like confirmation. I forgot the term for it, but pretty much you can't just, it may need a few different, what do you call them? I forgot if they're called Kafka apps or whatever it may be. A few different of the actual agents, Kafka agents, because I can't think about the real term right now, need to kind of acknowledge that they received the message before the message is counted as received. So let's say that happens and we have most of the cluster saying that it was received. Then we can guarantee that that was received. Load still matters, because now if you need that many acknowledgements, then like writes take longer. And then if writes take longer, that means requests for the API or API, the initial API, are going to take longer to process, which means if you have the same load, you're going to need more of those apps running. So you're gonna have to use some type of managed distributed infrastructure, distributed in terms of horizontal scaling, not vertical. You could scale vertically too, like just create bigger, but it may not be necessary to create bigger APIs or run the APIs on bigger hardware. Maybe you can just run more smaller APIs. It's not like there's, like, if you needed it bigger, that's more of like you're processing images, you're doing some really computationally intensive task. If you're just doing a lot of something, you just need to do more of it. If it's not heavy, pretty much. Let's say it says follow-up question. Let's say app 2 crashes and restart 3 minutes later. If your app take 3 minutes to restart, that's crazy. Did your whole cluster go down? Could that happen? Yes, technically it could. But I think 3 minutes is that's a little crazy. This is the federal government here. I know y'all can afford a better system. Like, you could spend a little more money to get this system to not be down like that. Like, and is it 3 minutes every year? That's okay. 3 minutes every year, that's good. I wouldn't be mad at you if you was only down for 3. Are we saying 3 minutes a day? But let's say it happens, however it happens. I don't know how it happens. Design topic to handle retries and replayability. Topic B. App 2 crashes. Topic B is just the... I go back to my solution. That's what documentation is for, y'all. You need to know. App 2. App 2 crashes or falls behind. I was almost about to get into that. SQS has a feature where a message could be called, and the subscriber who called the message needs to basically say, hey, I finished processing this message. So if Kafka does not do that, then I would put an SQS queue there. Maybe replacing the topic B with Kafka, replacing that with an SQS queue. The SQS, yeah, I got. I'm saying SQS queue, but I think simple query service, no, simple queuing service, queue, whatever. Yeah, I'd put a SQS there, and then app 2 would basically read from the SQS queue, and then if it doesn't get to process the message, then the message goes back onto the top of the queue so that it can be processed by another app 2 whenever an app 2 instance whenever it gets back online. Topic B gets flooded with alerts. That just means that the API is doing its job and there's a lot going on. So that just means we need to make flooded is not bad as long as it can handle the flood. So let it flood. If we start seeing degradations in service, like topic B, or not topic B, let's say the API keeps crashing or the Kafka cluster keeps crashing. Like, and that crashing means there was no topic online for X seconds, or that's an issue. If their half hour clusters keep going down, not half, if half hour Kafka instances go down, that's not a bad thing as long as we still have enough running to have the same type of acknowledgement that we need or that we said we needed. So that's something to keep in mind. But I'm kind of done with this interview, so later, y'all.